Hello, my Calc 2 student. Today we talk about exponential function, differential, and integration. This is section 5.4 in your book. First, we defined our exponential function. Here will be definition. Definition. If your function f(x) is natural logarithmic function ln x, then inverse function, who we talked yesterday, it was this, or last time, e exponent x. Okay. How you remember, e is some number greater than 1. This means exponential function graph, which will be, if you have x-axis, y-axis, oops, this is 1, and here it will be. This is your graph. For exponential function, it have its all property how you have. It's true for exponent. This means e exponent a times e exponent b. It will be e exponent a plus b. Second, e exponent a divided by e exponent b. It will be e exponent a minus b. Third one, e exponent a. Then exponent m is e exponent a times m. And now we can prove some theorem. Theorem 1. Let's tell us differential for exponential function is with base e is exactly same function. And the second one, if you have the x is e to the power u, it will be e to the power u times u prime. Well, how you can easily see, we need proof only first fact, because second one is got to from first and use chain rule. Okay. Proving. Compose the two inverse function. We have natural log from e exponent x will be exactly x. Found derivative, both sides our equation. We have this is derivative logarithmic function equal 1, because derivative x is 1. This means derivative exponential function, it will be exponential function. That's exactly for what we need proof. Second one more time, is use this formula and chain rule. Now doing some examples. A. Let's go. Our function is e exponent 2x minus 1. Derivative will be same function multiplied by derivative power. Derivative power, it will be 2. This means twice e exponent 2x minus 1. Minus 1, yes. Doing something from your textbook. For example, number 42. What is it? Here is function is y equal x to the square e exponent minus x. Here we can see this is product two function. One is power function, one is exponential function. And derivative, we use power rule, product rule. We have 2x e exponent minus x. Now, derivative, okay, I'm right, plus x squared, derivative e exponent minus x, it will be e exponent minus x, and derivative negative x, it will be negative 1. This means here we have 2x e exponent negative x minus x squared e exponent negative x. One more example. It's example 48 from your textbook. It will be y equal e exponent x minus e exponent minus x over 2. In the future you study this is some special type of function, but right now we found derivative use formula for exponential function. Divide by 2, it means multiplied by 1/2. Here I need derivative of exponent x. This will be exponent x and minus derivative e exponent negative x. And here is multiplied by -1. This means change. And here I have e exponent x plus exponent minus x over 2. Okay. How we can integrate our exponential function? Here we have some theorem number 2. Tell us first formula, integral from e exponent x dx. It will be e exponent x plus c. Second formula tell us if you have integral e exponent u du, it will be e exponent u plus c. We don't need proof anything because what does mean integral equals some function? This means derivative this function equal function who stay inside integral. But we prove this fact now. This means this is proving theorem number 1. Okay, doing some examples. First I took in something very similar. For example, e exponent 3x dx. How do you remember we proved this theorem about what happened if you have some coefficient? It's got to 1 over this coefficient here and e exponent 3x and plus c. This is example A. Example B. Let's go, we have something like e exponent 1 over x squared dx. And here we need doing some our power something. Use substitution. This means 1 over x, our exponent. Let's go, it will be u. Then derivative will be minus 1 over x squared dx. It will be du. This means exactly what we have, except we don't have minus. This means here it will be minus integral e exponent u du. Let's give us minus e exponent u plus c, who is equal minus e to the negative minus e to the 1 over x power plus c. Great. Sometimes this integral looks scary, but very simple solving. For example, c, we have integral from negative 1 to 0 e exponent x cosine from e exponent x dx. Simple substitution, it will be e exponent x. Okay, it will be e exponent x u e exponent x dx. It will be du. We have integral, it will be cosine u du, but because we have new variable, this means we have new border. If x is equal -1, e exponent x will be e to the -1 power, this means 1 over e. If x is equals 0, e exponent x's will be 1. This means integral from cosine is sine u. U change from 1 over e to 1. It will be sine 1 minus sine 1 over e. You can use your calculator for evaluate, but I think it's good enough. Okay, doing one more example. This is number 102 in your textbook. This will be integral from square root of, just a moment. No, it's only integral without borders, sorry. E to the x power minus e to the negative x power divided by e to the x power plus e to the negative x power dx. I think you can say easy substitution. It will be e to the x plus e to the negative x. It will be u. Take a derivative. It will be negative x dx. Oops. Dx. Sorry. Du. And we have here du over u. All you remember, it will be natural log absolute value u plus c, or it will be natural log e to the power x plus e to the power negative x plus c. I'm not write absolute value here because each of term is not negative, more strong positive, and if you add, you have positive here. Okay, and our last question is 114 from your section 5.4. It will be integral from 0 to square root of 2 x e to the negative x squared over 2 dx. Simple substitution here is your power, you substitute negative x squared over 2. Let's go, it will be u. Then is minus x dx. It will be du. This means your new integral, it will be e to the u du, but because you need minus, this means you have minus here. And counting new border, if you plug in for x equals 0, this means u will be 0. If you plug in square root of 2, you have 2 over 2, it will be negative 1. Looking here we have lower border is greater than upper border. This means we write as normal order. We have integral from negative 1 to 0 e exponent u du. Because we switch order, this means have minus in the front, but we have minus and it will be positive, okay? And here we have e to the power u from negative 1 to 0. It will be 1 minus e to the negative 1 power, this means 1 over e. You can write like e minus 1 over e. This is final answer. Okay, I think it's all what I want to show you for section 5.4. Okay. One more time, make it your homework, and if you have any question, ask me.